Look around you. Take a moment to really notice the world you're living in, the city streets, the gadgets in your pocket, the hum of technology all around. It's easy to take it all for granted, but there's a hidden story woven into the fabric of our daily lives. Pick up your smartphone, glance at your earbuds, or think about your car. These aren't just conveniences, they're marvels of modern engineering, and they all have something in common. Chances are, you're using something that wouldn't exist without rare earth elements. From the moment you wake up to the moment you go to sleep, these elements are quietly working behind the scenes. These 17 elements, names like neodymium, yttrium, and scandium, are the secret sauce in modern technology. They might sound exotic, but they're essential, and they're everywhere. They're not rare because they're hard to find, but because they're hard to extract and process. In fact, they're scattered all over the Earth's crust, but getting them out in a usable form is a complex, delicate process that requires advanced technology and careful handling. You won't find pure neodymium lying around. Their magic happens when mixed with other materials to create powerful alloys. Scientists and engineers spend years perfecting these combinations to unlock new possibilities. A pinch of a rare earth element can make metals stronger, heat-resistant, or give them powerful magnetic properties. This is what allows your headphones to sound crisp, your car to run efficiently, and your computer to process information at lightning speed. They're the ultimate supporting actors, enabling the star technologies to shine. Without them, the show simply couldn't go on. Rare earths aren't just in consumer gadgets, they're vital for wind turbines that generate clean energy, MRI machines that save lives, and satellites that connect the world. Need a magnet a dozen times stronger than normal for a tiny earbud? That's the power of rare earths at work making the impossible possible, or a jet engine blade that survives extreme heat. Rare earths make it happen, allowing planes to fly higher, faster, and safer. That's rare earths at work. They're the unsung heroes, quietly powering the innovations that define our age. Their influence is everywhere, in your TV's vibrant colors, your car's tiny motors, and the guidance systems of fighter jets. They're the reason your screens are so bright and your devices so compact. They're the invisible foundation of our high-tech world, connecting everything from entertainment to transportation to national defense. Without them, much of our modern life simply wouldn't function. Imagine a world where your favorite devices just stopped working. They're the hidden power, the quiet enablers. They keep the gears of progress turning, often unnoticed, but always essential. Understanding rare earths is understanding the real story behind the technology we depend on. Next time you use your favorite gadget, remember, there's a world of science and ingenuity inside, powered by elements hiding in plain sight. Let's talk about magnets. Not the fridge kind, but the super-powered ones inside your gadgets. The most significant use of rare earths is in making neodymium magnets, the strongest permanent magnets known. These tiny powerhouses make wireless earbuds sound rich. Give your phone its buzz, and let laptops read data at lightning speed. They're why our devices can be so small yet so powerful. In cars, rare earth magnets drive motors for seats, windows, and airbags. Even factory robots rely on them for strength and precision. Without these magnets, our gadgets would be bigger, clunkier, and less capable. It's not just clever engineering, it's clever chemistry. Rare earth magnets are the silent force powering our modern lives. They're the magnetic pulse in the veins of technology. Electric vehicles are leading the green revolution, transforming how we think about transportation and energy consumption, but their power comes from rare earth elements, which are essential for their advanced technology. High-performance EV motors depend on neodymium, dysprosium, and terbium magnets for strength and efficiency. These elements are crucial for creating the powerful magnets that drive the motors. These magnets deliver incredible torque in a compact size, maximizing range and performance. Without them, electric vehicles wouldn't be as efficient or powerful. While some companies try to avoid rare earths, the best motors still rely on them. The challenge is finding sustainable ways to source these materials. Rare earths are also in EV sensors, speakers, and small motors throughout the car. They are integral to the vehicle's overall functionality and user experience. Wind turbines use tons of rare earth magnets to generate clean energy. This shows how deeply embedded these materials are in our green technologies. The paradox: building a green future depends on materials that are tough on the environment to produce. Mining and processing rare earths can cause significant environmental damage. We're solving one problem while creating another. the environmental cost of rare earth mining is a significant concern. Our clean energy transition is deeply tied to these critical minerals. The demand for rare earths is only going to increase as we push for more sustainable technologies. The supply chain is complex, dirty, and geopolitically charged. Navigating this landscape is crucial for the future of green technology. National security isn't just about soldiers and ships, it's about rare earth elements. Modern defense systems, from guidance chips to warships, rely on these materials. An F-35 fighter jet contains over 900 pounds of rare earths, a nuclear submarine, even more. Rare earth power, radar, sensors, and the magnets in advanced generators. In aerospace, yttrium and ceramic coatings keeps jet engine blades from melting at extreme temperatures. Without these elements, modern aviation and military tech would take a huge step backward. Our most advanced technologies depend on a few obscure elements. It's a quiet but critical dependency. The battle for the future may hinge on control of these minerals. Where do rare earths come from? The answer, overwhelmingly, is China. These minerals, essential for everything from smartphones to fighter jets, are dug out of the earth in vast Chinese mines, often in remote regions. China doesn't just mine rare earths, they dominate nearly every step of the process. From extraction to refining, and all the way to manufacturing, China's grip is nearly absolute. The numbers are staggering. China produces about 69% of the world's rare earth oxides, the raw materials that power modern technology. But it's not just about mining. China processes 91% of the world's finished rare earth elements, turning raw minerals into the high-purity materials needed for advanced manufacturing. Even when rare earths are mined in places like Australia or the US, the story doesn't end there. Most of these minerals are shipped to China for processing, because few other countries have the capacity or expertise to do it at scale. China's dominance is no accident. Decades ago, they invested heavily in rare earth infrastructure, accepted the environmental costs, and undercut global competitors with low prices. This strategy paid off. Today, China not only controls the minerals but also the industries that rely on them: electronics, renewable energy, electric vehicles, and more. This gives Beijing enormous leverage over the global economy and even national security. As countries scramble to secure their own supplies, the world now finds itself in a precarious position, with supply chains vulnerable to disruption and prices subject to China's decisions. Nations are increasingly aware of their dependence on a strategic rival for materials critical to their economies and defense. China has already shown its willingness to restrict exports during political disputes, using rare earths as a bargaining chip. When China tightens the tap, global industries, from tech to automotive, feel the shockwaves instantly. Production slows, costs rise, and uncertainty spreads. The message is clear: China holds the cards, and it's not afraid to play them when its interests are at stake. This strategic advantage has far-reaching consequences, shaping global trade, diplomacy, and even the balance of power. The rare earth supply chain isn't just about minerals, it's a geopolitical pressure point that will define the next era of global competition. Rare earth elements aren't actually rare in the ground. Cerium is more common than copper. Even the rarest are far more abundant than gold. The name comes from the uncommon earths where they were first discovered. The real challenge is finding them in high enough concentrations to mine profitably. Rare earths are usually mixed with other minerals, not found in pure veins. Each deposit requires a unique, complex extraction process. The rarity is in the difficulty and cost of processing, not in the earth itself. Countries like Australia and the US have reserves, but can't match China's processing scale or price. The bottleneck is turning rocks into usable metals, not finding the rocks. The world let China dominate rare earths because processing them is dirty and polluting. Extracting rare earths involves dozens of chemical steps, generating toxic waste and radioactive byproducts. For every ton of rare earths, thousands of tons of waste are produced, often stored in massive, leaky dams. The carbon footprint is huge. Producing neodymium is more polluting than making steel or copper. Satellite images of China's Bayan Obo mine show the environmental cost: vast tailing ponds and scarred land. China's lower environmental standards make their rare earths cheaper. Western countries can't compete without sacrificing their own landscapes. We've outsourced the pollution for our high-tech lifestyle to China. When one country controls 91% of a critical resource, it becomes a weapon. China's rare earth dominance is a tool of geopolitical leverage. In 2010, China halted exports to Japan during a dispute, sending panic through tech industries. More recently, China tightened export controls, increasing global vulnerability. The US and others are now scrambling to respond, sparking a new kind of trade war. China can squeeze supply, the US can retaliate with tariffs. It's a high-stakes standoff with no easy answers. The US has its own leverage, ultra-pure quartz sand for semiconductors, needed by China. Geology creates strategic choke points and new forms of power. The world is racing to break its rare earth dependency. Countries are investing in new mines, processing plants, and alternative technologies. Restarting old mines and building refineries outside China is underway, but it's expensive and slow. Recycling e-waste for rare earths is a promising secondary source, reducing both mining and electronic waste. Innovation is key. Researchers are designing magnets that use fewer or no rare earths. Some EV makers are already shifting to alternative motor designs. The ultimate goal, a resilient, secure supply chain not controlled by a single nation. The race is on to secure the future of technology.